Nandita, Assistant Professor, Department of CSC. In last class, we see the bus structures. What are the bus structures? And in this are data bus, address bus, control bus. What are the things? Why we use that? Like that we see in the last session. Now we're going to see the single bus structure. Single bus structure is nothing but a simple computer organizations where one common bus is shared by the CPU, memory, input-output device. The same set of lines, that is wires, is used to transferring data, address and control signals. Here also there are the components like a data bus, address bus and control bus. Already we say that it transfers the actual data in the data bus, transfers the memory input output address in the address bus, and transfers the control signals like read or write in the control bus. When we move for the operation, we see address phase, control phase and data phase. When the CPU wants to fetch any instructions data, in address phase, CPU puts the address on the address bus. In control phase, CPU sends the control signals on the phase. Example, memory, read. In data phase, data is transferred via the data bus. Here, only one transaction can happen at a time since all the components share the same bus. There are some advantages and some disadvantages are there. Before that, we see the components and functioning single bus structure. Here the components are the CPU, memory, input-output device. CPU is nothing but it's a heart of the computer system. Without CPU, we can't do anything in the computer. It processes the instructions and controls the flow of the data through the bus. Here memory is nothing but it stores the data and instructions that the CPU needs for processing. This memory can include RAM, that is a random access memory, and ROM, read only. And move for the input-output device. In input-output device, there are peripherals that allows the computers to interact with the outside world, including the keyboard, mouse, monitor, printer, etc. And some disadvantages are there, that is simple and low cost, and also easy to design and expand. Just connect device to the same bus. And disadvantages are there, some bottleneck problem, performance degrades, and slower input-output device. In advantage, the design is simpler, which makes it easy to implement and manage. And also we use a single bus to need a multiple bus, making it cheaper in terms of both hardware and wiring. And fewer components leads to easier troubleshooting and repair processes. And disadvantages are already said at bottleneck, that's only one operation can be done at a time. Performance degrades is nothing but more devices are connected. And slower input-output device, it may holds the bus, delaying the CPU and the memory. And also a single bus structure is a computer organization where CPU, memory, input-output device share one common bus for address, data and control. It is simple and cost-effective, but suffers using bus connections and limited space, that is a limited speed, because only one transfers occur at a time. These are the things we saw in the single bus structure. In already we see that the class of occurs single bus structure is moved for only in the performance. And also here we see some nature of communications, instruction execution in single bus. Nature of communication is nothing but all components are connected to the same communication path. Only one component can transmit at a time, others must wait. Here instruction execution in single bus means instruction fetch, operand fetch, execution and result storage. In instruction fetch, CPU places the instruction address, that is a memory sends the instruction, CPU reads it. Operand fetch, CPU places the operand address, memory input output sends, operand CPU reads it. Execution and result storage, CPU executes and write back via the same bus. And authentication, when multiple devices requires a bus arbitration logic decides who gets control. That's the method is priority, round robin. And performance limitation in bus contention, bandwidth limitation, memory input output speed mismatch. And hardware requirements like a bus controller, latch, that is a ALE signal, tri-state buffers. There is a type of transfers on a single bus like memory read-write, input output read-write, DMA transfer. And some users typically is found in simple microprocessors and early computers like Intel 8085, 8086 systems. Still used in small embedded system because of low cost. When you single bus, it must cheap, simple, but slow. That's the bottleneck. But in multiple bus, it's expensive, complex, but support parallel transfers. These are the things comes occurs under single bus structure. Thank you guys, and let me see you in the another session.